Now we are discussing about speed control of DC motor using thyristor. So here we have connected the DC shunt motor. We are giving the supply to this motor in parallel. That's why it is called as a DC shunt motor. If we provide the supply to the motor in series, then it is called as a DC series motor. This is a single phase AC supply. Here it is bridge rectifier. You have studied in previous years. This bridge rectifier converts this AC to pulsated DC. This is the pulsated DC. This waveform whatever we are seeing, that supply we are directly giving to the motor through the thyristor. And this supply we are giving to the circuit which is connected here, variable resistor and inductor. Mainly we can control the speed of the DC motor by using two factors. One is armature voltage and the second one is the magnetic field lines or the magnetic flux is passing through the poles of the motor. This by changing the magnetic flux per pole, we can change the speed of the motor. The speed of the motor equation is given by EA minus IA RA, where EA is the armature voltage, IA is the armature current, RA is the armature resistance, and phi is nothing but flux per pole, K is constant. We can either control the speed of the motor by changing EA, or we can control the speed of the motor by changing phi. But presently we are not concentrating on this, we are concentrating on this. By using the SCR, whenever we are giving the triggering pulses to this gate, this is the trigger pulse circuit. Whenever we are giving triggering pulses to this gate, see, this is the output. We have given trigger pulse here. For one input cycle, this is a rectified output. So here, for the second input cycle, the pulse is given here. So SCR starts conducting from this point only. So output will be this. This is the output. At this point, the SCR should turn off. Yes, obviously the SCR turns off. But the important point you have to remember is, even though the SCR is turned off, the inductor is charged. Now the inductor finds a path through this freewheeling diode to discharge, and that will rotate the motor again. So small amount of time, for a small amount of time, you will observe the voltage is continuing. But the current, because why? Why it is providing the current to it? Because inductor does not allow sudden changes in the current. Here suddenly the current is trying to become zero. Inductor will oppose. Because of this factor, the inductor is saying, I am ready to provide the energy. Inductor gives whatever the energy it has. So it fully discharges. Inductor fully discharges. That's why until the current becomes zero, you will observe the voltage. But there is a difference between the current here and current here. When the current is flowing from this to this, you are seeing the pulse, the voltage is positive. When the current is decrementing, suddenly you are observing a negative voltage. That is indicating that there is a change in the supply. Previously, it was plus and minus. Now, it is minus and plus. Example. Okay, this is how by using the SCR, we are controlling the speed of a DC motor. Similarly, we can give the triggering pulses for each full wave rectified cycle. But we have to make sure that the firing angle or the pulses, we should not give immediately after the SCR is turned off, because you are observing still, even though the SCR is turned off, the voltage is not becoming zero. That's why until the voltage becomes zero, until the current becomes zero, we should not give the triggering pulse immediately after the SCR is turned off. That's why we maintain some gap and we will give some triggering pulses after a certain point. So here we have discussed, we are controlling the speed of a DC motor. For controlling the speed of the DC motor, we are using the thyristor. This is the single phase AC supply. The single phase AC supply we have given to the bridge rectifier, and the output of this bridge rectifier is pulsated DC. This pulsated DC we are giving to the motor through the thyristor, and also we are giving to the inductor through the variable resistor. Whenever we are changing the resistance, then the inductor can store more amount of energy. When the inductor is storing more amount of energy, then it will take more amount of time to discharge. That's why we should never take larger inductance. We don't want the motor to be operated in the reverse direction. We are only expecting the motor to be operated normally. That's why this value should be very low. If we keep the inductance as a larger value, then it will take this much time for discharge. We don't expect that. So for this circuit, we expect the inductance value is to be very much high, and the inductance value should be very much low, and this resistance should be high, such that only small amount of inductance. That inductance also suddenly, when we are cutting the supply from the SCR, motor suddenly, it never turns off. If you turn off your switch immediately, the fan will not turn off, because it is an induction motor. Whenever you take a device, whenever you take an inductor, whenever you suddenly turn off, it will not turn off. It takes some amount of time to discharge. Even though you have turned off, it will rotate for some amount of time. The same is applicable for any induction motor. Similarly here, that is AC motor and this is DC motor. There is a difference. But for this DC motor also, suddenly we are cutting off this supply. After cutting off the supply, for small amount of time, this is having the voltage. And for small amount of time, the current is continuing here. So this is how we control the speed of a DC motor by using SCR.